All right. Greetings, fellow grade 11s. It's Mr. Hlajaro Ike here, and welcome back to basics, right? So now what we are going to be looking at today, basically, we are going to be understanding our tree diagram. Look, I know tree diagram is one of the most, difficult concept for one to understand. But look, today it is the day you'll at least have an idea in terms of what you are required to do there. Now let's start. Now, firstly, they are saying now the girls hockey team has a match on Saturday. Now they are saying there is 85 percent chances Michaela will play goalie, right? So now they say if she does 70% chances will win, but if she doesn't, then 45% chances that the team will what? They will win. Now they want us to draw the diagram, the tree diagram. Now, what is important firstly is to always, link up your events, right? Now let's start here. So the first event that we are given, they are saying now, there is an 85% chance Michaela will play a goalie, right? So which means if you can firstly draw your first branches, right? So which means you are going to have what? You are going to have the one of a goalie and the one of not goalie, right? Now, which means you are going to say now this the event for Michaela to play goalie. This is going to be therefore not playing a goalie, right? Now, you know that now if they are saying the chances that she will play goalie, it's 85%. 85% in terms of probability can be represented by what? By 0.85, right? So which means the probability or the chances of goalie is 0.85. And now the probability of not goalie then, which means it's going to be what? It is going to be 0.15. Altogether. Now that is going to be that. Now, they are saying now from there, after that, now they are saying there is 70% chances that now, if she plays goalie, now, there is 70% chances that they will win, right? So now, what is it that you are going to do? We are going to say now, look, if now from this branch, remember this is if she is playing goalie, you are going to say now if she is playing goalie, then therefore here it's going to be what you are going to also have another two branch of events, which will be what now, which will be now the chances of what of winning or not winning. Now if she plays goalie, right, what will be the chance of the team winning? And obviously if the team is not winning is what it is losing, right? Now they are saying the chances of winning it is what? It's 70%, which means it's 0.7. And now if the chances of winning is 0.7, therefore the chances of not winning will be what? Will only be 30%, which is 0.3. Out again. Now, however, if you can continue now they say now but if she doesn't play there, there's basically 45% that they will win the game. Now, if she is not playing a goalie, the chances of the team winning will be what? Will be only 45%, which means now, remember, we are saying now the chances of again winning and also not winning, which is losing, right? Now, if this Michaela is not playing goalie, now the chances of a team to win now it is going to be only 75%, which is 0. What? Which is 0.45. I would get. And the chances therefore of losing it will be what? It will be 0.55. Remember, all these events must add up to 100%, right? So if you can add this 0.7 and 0.1, 0.3, it will give you the sample space of 1. Similarly here, 0.4, 0.45 and 0.55, it will also give you 1, right? Altogether, which what each and every all the branches must give you, right? Altogether. Then now, what is it that we are then going to do now from here? The question is, now, what is the probability that Michaela playing a goal and the team win, right? Now we are going to come back here and say now We want the probability of what? The probability of Michaela playing a goalie and what? And winning. And winning. What will then be that probability? Now, firstly, the probability of playing goalie is what? It was 0.85, isn't it so? So this is going to be what? It is going to be, let's start here. Now, the probability of firstly playing goalie is going to be 0.85, which is going to be this one, 0.85, multiplied by what? Now, and the team winning. So this is going to be 0.85. And then now this other one is going to be what? This is going to be goalie 0.85 and winning is going to be 0.75. Okay. So this is goalie and winning, right? And remember, and means multiplication. So this is going to be same as 0.85 multiplied by 0.7. And what is going to be our probability? Therefore, there it is going to be what? The probability that you are going to get, it is 0.6 altogether. So therefore, that is going to be that particular probability. Now, let's look at our number 2 now. They say, what is the probability of the team losing the match on a Saturday? So now we want a probability of what? We want a probability. Now, the probability of the team losing the match on Saturday, right? Now, what will then happen there? We are going to say, for us, the probability of losing will be what? This one. Let's start here. Now, here, you have the probability of losing, isn't it so? So you're going to say, you always start here, which means you're going to say, look, now here, the probability of the team not losing, it will be if she plays goalie. Remember, the team can still also lose altogether. So it's going to be this Michaela playing goalie and the team are also losing. And also similarly, even if she's not playing goalie, the team will still what? Will still lose, which is the rate cycles altogether. So which means it's going to be those, which means it's going to be the probability of what? Of Michaela playing goalie and what? And losing. Plus again, even when Michaela is not playing the goalie, but the team is also what? Is also losing altogether. So which means these are going to be the chances, which means you're going to multiply these two and add them together. So this is going to be 0.85 multiplied by 85, yes, multiplied by 0.3, which is the losing. Plus the other one is going to be 0.15 multiplied by what? Multiplied by 0.55. So the probability of what? The probability of losing is going to be 0.34 altogether. So basically, this is how we tend to understand the probabilities of our tree diagram. But now let's get another example and see in terms of what can we do here. All right. Now I want us to look at this second example, right? Now they say a bag containing 4 red metal balls and 5 blue metal balls and 3 green metal balls. Now they say a ball is chosen at random and not replaced, and then also another ball is chosen at random again, which means basically if both of these balls are chosen at random, which means we are having how many balls which are chosen. Look, they say a ball is what? A ball is chosen at random and not replaced, and then also another ball is chosen, which means we are having 2 balls that are being chosen in there, right? Now let's get that. Now they say use the tree diagram to determine the probability of the following: a blue ball in the first draw. Right now, what is it that we are going to do? It is important that we start by trying and drawing this tree diagram of these in order for us to understand these particular questions. Now, how are we going to draw this? Now, let's start here. How many balls are we having? Right? So in this case, we are having 3 balls, right? 3 metal balls. Let me represent all these 3 events, right? We are having 3 of them. Now, the first one being the what? The first one being the red ball, right? Being the red ball, and the second one being the what? The blue, right? The blue, and the last one being the what? Being the green one. Now, what is important to understand is that we are having a totality of 4 plus 5 plus what? It's 4 plus 5 plus also 3 balls altogether, which means the total sample space of the number of balls that we are basically having here, it is what? It is going to be your 12, right? So we are going to have 12 balls in totality, right? Because it's 4 plus 5, which is going to give us 9, plus 3, which is going to give us 12, right? Now, but now, if we can check what is the probability of them firstly choosing a red ball, right? How many red balls are you having firstly at first? You are having 4. So which means you're having 4 red balls out of 12, right? Which means the chances of them taking out a red ball firstly, it is 4 out of 12. Then now the blue balls are going to be what? It is 5 out of what? Out of 12, while the green one is going to be what? It is going to be 3 out of also what? Out of also 12 altogether. Now that is going to be the first that is going to be your first diagram. Now the second part, now they say now another ball is chosen altogether. The first one is not replaced. Now we are choosing the second one. Now what is it that you know already? Now if the first ball is already chosen, now if we are asking in terms of what are the chances of you picking now a second red ball, now look, if they've already chosen the red ball at first, the chances that they are choosing the second ball now is going to be what? It is going to be 3 because there is one ball that they have left already, right? And now obviously the totality of balls, they are no longer going to be 12, but all of them are going to be what? Are going to be 11, right? And now, which means now they are going to, it's going to be 3. It's going to be 3 out of 11 for the first one, for the red one. Remember, this is the red. Now, for the blue ball, now this one is going to what? Because we are already choosing the red one. So, which means the blue and the green remain the same, which means it's 5, but the totality is still 11 because one ball already left out to get. Then now, and the green is also going to be what? It's going to be 3 out of 11. Altogether. Now, let's say we go to this one now. Let's say we go to the blue balls. Now we come back here. We say now we want to find out for the blue balls. What is it that we are going to do? Let's do it this way. Now, firstly, we are going to say now for blue. Now, if they pick a blue from this 4, right? Remember, we are saying this is green. This is supposed to be red, blue, green, right? Now let's start with the red one. Red one now, if you are in a branch for blue, basically you are taking another blue ball. What is it going to be? Now the red ball will be what? The red ball now will continue to be what? Will continue now to be 4. Isn't it so? Will continue to be 4 out of what? Out of 11. But the blue ball, because in this particular branch, we are taking that particular blue ball. So it is the one that is going to be what? That is going to be 4 out of what? Out of 11. Remember, the 11 is because the first ball is already taken out. And then the green will continue to be the same as what? Will continue to be same as 3 out of 11. Altogether. And now when we then go to the last branch to see in terms of what will then be the representation of the last batch. Now look, for this last one, now let's see. So we are looking for the green one, right? So let's start here. Now we are going to say now, look, if here for green, you are also taking a green ball, what is it going to be? Now you are going to be left with what? Firstly, the red ball now will be what? The red ball will be same as what? Will be same as 4 out of 11, while the blue ball will still be 5 out of 11. But the what? The green now, because we are taking one from the green side now, it is going to be what? It is definitely going to be same as what? It is going to be 2 now out of 11 because we have taken one. Look, and look, in all these branches, if you are observing, for the branch of red, we were taking a red. That's why the red number, decreased. For the branch of blue, we are taking another blue. That's why the blue moved from 5 to 4. And for the branch of green, we are taking a green. That's why the green moved from being 3 to 2. Okay. So basically, that's how you do it when you are understanding your tree diagram. Altogether. Now let's see in terms of what is the question now require us to do. Now the first question is, now if we can represent the events here. The first one, before we even continue to answer this question, how can we represent this? Now the first event represent what? Red and red, right? So this is the probability of red and red. The second one, look, the first one is red, but the second one is blue. So this is red and blue. And now for the third one, it's going to be red and green. And then again, for the first one, it's going to be blue and red. So it's going to be blue and also what? And red. The second one is going to be blue and blue, which is going to be the PP. And now the third one will be what? Will be B and green. Isn't it so? And when you go to the other one, it's going to be green. And what? Remember here, it's also red, it's blue, and it's green. So the first one is going to be what? It's going to be basically green and red. The other one is going to be what? It is going to be your green and blue. And the last one is going to be what? It is going to be green and green altogether. So which means this is basically the totality of all these particular outcomes. Right? Now, we are saying now what is going to be the probability of what? Of a blue metal ball. The first question want us to determine basically what is going to be the probability of a blue metal ball. Now, let's see. So for a blue metal ball, we are going to come back and here and say, now what is going to be the branch of a blue metal ball, right? Look, you can have your blue here. This is for blue, right? So which means this is going to be the 5 over 12 and what? And 0/4, because either whenever you are, even if you are having the green, or rather, even if you are having the red, you are still having the blue, right? Out together. So this is going to be still a blue. Even if you are having the blue first and blue again, you are still having the chances of blue. Even if you are having a blue first again and then green, you are still having the blue. Out together. So which means this is going to be what? The probability of what? The probability of blue, basically. The probability of blue is going to be what? It's going to be given by what? It is going to be given by 5 over 12 multiplied by what? Multiplied by 4 over 11, right? Plus, isn't it so? This is the first event, these first two events. Then the second one is what? It's again, it's same as 5 over, it's going to be same as 5 over 12 multiplied by what? Multiplied by 4 over 11. Plus the last one is going to be same as again 5 over 12 multiply again by 3 over 11 altogether, because all of these, they represent the probability of blue. And when you add this correctly, the answer that you're going to get, 0 point what? 0.42 altogether. So which means this is the probability of blue, right? Now let's look at the second one. Now for number 2, remember this was number 1. Now for your number 2, what is it that you are required? Now they say now, secondly, now a red metal ball, then a green metal ball, right? So which means firstly they want us to have the red, then after the green, right? So what is it that you are going to do? Let me try and make this to look very nice. Let's see. Now, firstly, the probability of red, they want the probability of red, then green, right? Red, then green. Altogether. So what is it that you're going to do? So basically, this is same as red and green. Now we are going to say, what is the rate? What is the rate that you are having? The rate that you are having is this one, right? Which is the 4 over 12. And after the 4 over 12, they also want what? They want the green. And then the green one is going to be, which one is going to be this 3 over 11. So which means this is going to be basically the same as what? 4 over 12 multiplied by what? Multiplied by 3 all over 11. And the answer that you are definitely going to get there is going to be 0.09 altogether. So that is going to be that particular probability. And now for your number 3. Now, hopefully your number 3 will squeeze here. Let me try and make up some space for our number 3. Let's write our number 3 in here. Now, in here, what is it that they are requiring us to do? Now, for number 3, they say now 2 metal balls are of the what? Of the same color, right? I'm tempted to just come here. Now, look, the same color, look, you can have red and red. You can have blue and blue. and you can have green and green, right? So those are the probabilities of the same color, because all of the other ones, they are combination colors, right? So which means the probability of what? This is going to be the probability of red and red, then what? Or what, the probability of blue and blue, or the probability of what, green and green, right? That's the probability of the same color. And what will that be then? Let's make up some space and see. Now, what will that be then? Let's see. For green, for red, firstly, it is 4 over 12 multiplied by what? 4 over 12 multiplied by 3 over 12 plus, let me use a different color. For the blue one, it's what? It is 5 over 12, 5 over 12 multiplied by which one again? Multiplied by 4 over 11. How to get? And for this particular last one, let's use again another color. We are going to say plus, what is going to be this other one? The green and green is going to be 3 over 12 plus what? Plus your 2 over 11. And that's basically going to be the probability of the same color. And when you plug this in your calculator and see in terms of what answer you are going to get, let's see. So this is same as now 4 over, let's punch in our calculator. This is going to be 4 over 11. Then multiply by your 3 over 12, which is going to be 1 over 11. Then we add this with what? With 5 over 12. 5 over 12 multiplied by 4 over 11, right? And what is going to be that? This is going to be that particular answer. Then we say plus what? Plus 3 over 12. 3 over 12 plus your 2 over 11. And then the final answer that you're going to get that the probability of the same color is going to be given by 0.67. How to get? So basically, this is how we do our tree diagram.